Hey guys, this video is going to be covering the Chapter 5 and Chapter 6 test review. I've already put the questions that you need to do on a PowerPoint slide, and I've already posted the answer key as well. So what I would suggest you do is you don't have to, unless you feel like that you really need it, you don't have to sit through this entire video. I'm mainly making this so that after you do the practice problems on your own, you check your answers. If they're not right, this video is meant to be a reference that you could come back to. So I will have I'll have the page number and I'll have the number, and it will go in order of how it's listed on the PowerPoint slide. You can fast forward to whatever problem you need to see worked out if you missed it. So like I said before, only use this as more of a reference video unless you really do need the walkthrough of every single practice problem. All right, so we're gonna get started. We're on page 365, and the first set of questions we're gonna do is 3, 7, and 9. Okay, so on number 3, notice that we don't have parentheses. The main thing you want to look out for is are there parentheses or not, and then you want to look at the exponent and see if it's being raised to an even or an odd power. So in this case, because there's no parenthesis, what this is saying is what is the opposite of 5 to the 4th? So what I need to do first is 5 to the 4th. So 5 to the 4th would be 5 times 5 times 5 times 5. So you can do that in your calculator if you need to, but basically what it comes out to is 5 times 5 is 25. 5 times 5 is 25. So 25 times 25, which is 625. Now that's not my final answer because 5 to the 4th is positive 625. What's the opposite of positive 625? Negative 625. All right, here we have the same kind of issue going on. There's no parentheses on this one. So what is the opposite of 6 squared? So 6 squared is 36. What is the opposite of 36? Negative 36. Now let me show you, it wasn't in the problem, but let's say this had been negative 6 squared. Then what this would be asking is what is negative 6 squared? Not is what is the opposite of 6 squared. So negative 6 times negative 6 is positive 36. So that would be the difference there, okay? All right, now this we have 3b to the 0 power. Think back what we learned on as far as what does it mean if it's raised to the 0 power. So the rule on that is anything that is raised to the 0 power, a number or a variable, in this case we have a number and a variable, is 1. So the reason it's 1 is because of the rule. Raising anything to the power of 0 is 1. All right, our next set of problems, I think I'm going to need space for, so I'm going to go ahead and erase these, but we're going to be doing number 14, 24, and 30 next. All right. All right, so 14. All right, so in number 14, we're starting to get into rules of multiplying. So your coefficients are going to be treated separately from your variables as long as the variable is the same base. Remember, the rule is that you add the exponents when you're multiplying variables. So in this one, I'm going to start with the coefficients. -5 times 4 is -20. Move to my variable. I have a y to the third and a y to the fourth. So they're both the same base. So I'm going to go ahead and write y. The rule of multiplying the same base unit for a variable is you add their exponents. 3 plus 4 is 7. All right, number 24. All right, so now we're looking into, well, what happens if we divide exponents? So this is the rule where if you are dividing exponents, so you have one in the numerator and one in the denominator, they're the same base unit, you're subtracting the exponents, you're not adding them, so it's the opposite. Just think of it as multiply and division are opposites of each other. So as far as coefficients, I'm going to go ahead and start with that. Notice that we have 2 and 8. Both of them are divisible by 2. So if I divide 2 by 2, that becomes 1. So I'm not going to write a 1 on top just yet because I don't really need it. 8 divided by 2 is 4. So now my coefficients are gone. I'm going to move to the next term. So we have x on the top and x on the bottom. So I have a 7 on top and a 1 on the bottom. So that means I'm going to do 7 minus 1. So that's going to leave x on the top because it has the larger number to start out with. 7 minus this x gives me now 6 x's. And the x on the bottom is now gone because we subtracted it off. Then I have y. I have 8 on the top and 2 on the bottom. So because this number is bigger, the y is going to be on top. 8 minus 2 gives me 6. And now this y is gone. Okay, so this would be my final answer. All right, number 30. All right, now we're moving into another new rule. But when I say new rule, then we're talking about of what we've done so far. We have gone over this rule. When you multiply, you add the exponents. When you divide, you subtract the exponents. What happens when you raise a power to a power? You multiply the exponents. So in this case, notice 5 isn't raised to a power, so that means I'm just doing 5 to the second power. So that's going to give me 5 times 5, which is 25. Then I have a to the 6th, and it's being raised to the second. So 6 times 2 now gives me a to the 12th. Now notice this is also a fraction. So the rule for fractions is that the top gets treated separately from the bottom. So now that I've done the top, I need to do the bottom. B to the third is being raised to the second power. So that's going to give me 3 times 2, which is 6. There's nothing I can simplify, so we're done. All right, our next set of problems are going to be 45, 48, and 50. Oh, I think I started looking at something wrong. No, that's right. Oh, okay. I was doing it right. I thought I was looking at the wrong problem. Okay. All right. So what we're doing now, it says in the instructions, we're supposed to combine like terms. So I'm just going to go ahead and box some of our like terms. So we have an a squared b. Here we have an a squared b. Notice that I'm including the sign. That's really important. Let's see. We have a b squared. No more b squared, so I'm not going to box that. We have a q squared here, and I also have a q squared here. Just double check. Yeah, okay. All right, so these are our like terms. So we have the a squared b's that need to be combined, and we have the q squareds that need to be combined. So I'm just going to go in order from left to right. So we have 4 and negative 10. So that's going to give me negative 6. Actually, I'm going to move that up a little bit. All right, so that gives us negative 6. A squared b. All right, so those are done. Then my b squared doesn't have a partner, so I'm just going to write minus 3b squared. Then my q squareds, I have a negative 8 and a positive 7. So that's going to give me a negative 1. Since it's negative 1, I'm not going to write the number 1. I'm just going to write minus q squared, and that would be my final answer. All right, 48. All right, so notice we have this group of terms plus this group of terms. Even though there's a parenthesis dividing them, because this is an add, then the parentheses don't really matter. This goes back to that, the associative rule, the associative property. You can change the grouping as long as everything is being added. So what we're gonna do is just pretend that the parentheses aren't there. We don't really need them. And we're going to start boxing like terms. So before I start boxing, I'm only going to box it if it's a like term. So x to the 5th, there's none other than just this. So I know actually, well, I'll just wait to go through it in just a little bit. So I'm not going to box 2x to the 5th. Any more x to the 4ths? No. X to the 3rds, no. X squared, okay, so we have an x squared. Notice I did put its sign, and we have an x squared here. That might actually, unless I wrote it wrong, might be the only ones we can combine. Yep, that's right. So in this particular problem, we only have one set we can actually combine. So I'm just going to start rewriting the problem. 2x to the 5th plus 3x to the 4th plus 4x to the 3rd. For my x squareds, I have a positive 5 and a positive 4. So that's plus 9 x squared plus 7x plus 6. And that's my answer. All right, 50. Okay, actually, I think I'm going to erase it and do 50 by itself so I have enough space. Okay, So with number 50, this one's a little bit different. Okay, here's what makes this one different from the last problem. We have a group minus a group. So we can't just remove the parentheses and start adding everything together. This minus sign means that everything in this second set of parentheses has to have a sign change because it's saying minus this, minus this, minus this. So if I do minus a negative number, that means that it becomes positive. So what we're gonna do is rewrite the entire problem, but when we get to this second set of parentheses, I'm gonna actually change every sign that's inside, okay? So this still gets written the same. Don't change the first set. Now, 4x squared is positive, so it's gonna be minus 4x squared. xy is negative, so it's going to be plus xy. 9y squared is positive, so it's going to be minus 9y squared. Now that we have everything written with the correct sign, we're going to group it by like terms. So 3x squared is going to get a box because I have another x squared over here. Oh, whoops, didn't mean that plus to get in there. There we go. All right. Negative 7xy, I am putting the negative inside, and there's another xy over here. And then we have 7y squared and a negative y squared. All right, so we're gonna move in the order of left to write our final answer. All right, we're gonna do the x squareds first. We have a 3 and a negative 4. So 3 and negative 4 becomes negative 1. So I'm gonna put negative x squared. Then we have our xy's. I have a negative 7 and a positive 1. So if I do negative 7 plus 1, that gives me negative 6. So minus 6 xy. Then the last, we have our y squareds, positive 7, negative 9. So positive 7 and negative 9 make a negative 2. So minus 2 y squared, and that's our final answer. All right, number 60. All right, so we have a new set of directions. We are multiplying each expression. So the rule for when we have a polynomial times a monomial, so just one single term, notice there's no plus or negative, something that we're combining with 7b. What we're doing is we're just distributing this term to everything in here. Now, this can be either in the front or behind, you're still gonna go in a motion of left to right. So what we're gonna do is take 7b and multiply it times the first term, the second, and then the third. So always start with your coefficients. 7 times 6 is 42. Then we have a b to the third and just a b. So we're combining the same term, so that means we're adding exponents. 3 plus 1 is b to the fourth. Then minus. Well, actually, we don't really have to do minus yet. We're going to multiply, because if this was negative, it wouldn't be minus. So the next one, I'm going to look at this as a negative 4. Negative 4 times 7 is negative 28. Then 1b and 1b becomes b squared. Then I have 2 times 7. So that's positive 14. There's no b here, only 1. So I just have 1b, and that's my final answer. All right, next we have 62. All right, so now we have a binomial times a binomial. This is where we do our FOIL method, first, outer, inner, last. So first, 2x times 3x. 2 and 3 is 6. X and x is x squared. Then we have outer, 2x times positive 2. That's going to give me 2 and 2 is 4, and then the x. Then we have inner, negative 5 times 3x. So that's going to be negative 15 on the coefficients and x. Then we have last, negative 5 times 2 is minus 10. Look for like terms. Notice we have a positive 4x and a negative 15x. If I combine those, positive 4 and negative 15, that gives me negative 11. So my final answer here would be 6x squared minus 11x minus 10. All right, 70. All right, so you have two ways of doing this. You can do this term times each of these, and then this term times each of these in a horizontal motion, or you can use vertical multiplication. I feel like it puts it in a better organized manner to do it vertically. So I'm going to actually take the form this is written, and I'm going to show you how to do it vertically, because I feel like that it helps prevent more errors. So the way we do that is to take the bigger polynomial, and put it on top. And then what I'm going to do is I'm going to take this x plus 2 and I'm going to put it underneath. Okay, so I'm going to actually erase this along with the parentheses. And now I'm going to put a times and draw a line. Now, when we're doing vertical multiplication, this is the same thing as if you were doing, like, say, 625 times 103. Okay, you would take the first one, multiply it times each, then take the next one, multiply it times each on the next line below, and so on. So don't get mixed up. We also covered how to do vertical addition. Don't do it by addition, otherwise you're going to get it wrong. So you're not doing 1 plus 2. You're doing 1 times 2. So that times is important. So we're multiplying vertically. All right, so start with the last term on the bottom. So 2 is going to get multiplied by everything on top. So 2 times 1 is 2. And make sure you put the sign. So it's a positive 1 times positive 2 is positive 2. Positive 2 times positive x is positive 2x. Positive 2 times positive x to the 5th is positive 2x to the 5th. All right, now move to the next one. Now here's where, just as a reminder, when you're doing vertically, whatever you multiply out, always put the answer under a like term. So when I do x times 1 and I get the answer x, I'm not going to put it under the 2. That's not a like term. So I'm going to put it under the x's. So plus x. Now, x times x. That's a positive x squared. Now don't get mixed up. That's not 2x. X times x means you're adding the exponents. So plus, actually I probably should have written that, x to the 5th further out. All right, so x times x is positive x squared. Then x times x to the 5th. So once again, we're adding the exponents. 1x plus 5x's is going to be an exponent of x to the 6th. So instead of actually putting it under here, because this is a 5th term, I'm going to put it in front of it because now I have them all lined up with like terms or different terms. So we're going to add it all together straight down. X to the 6th, you always want the highest exponent coming first, plus 2x to the 5th, plus x squared, plus 3x, plus 2. Okay, so going downwards, we are adding. All right, so we're only looking at the coefficients. We're not looking at the exponents like we would in multiplication. And that would be your final answer for 70. All right. So you might be looking at this, well, wait a second, what do I do? Because there's nothing written but one binomial and an exponent. So what does this mean when you have an exponent? It means you're multiplying that same thing 3 times. So I'm going to rewrite it to look like this. X plus 7 times x plus 7 times x plus 7. All right, so any case that you have 3 polynomials that are being multiplied, you got to do 2 first and then multiply your answer times the 3rd one. So what we're going to do is we're actually going to multiply using the FOIL method the first 2. So let's do that first. First, x times x is x squared. Outer, x times 7, that's plus 7x. Inner, plus 7 times x, so that's another plus 7x. Last, positive 7 times positive 7 is 49. Add the like terms, 7x plus 7x. That gives me x squared plus 14x plus 49. I'm going to put that in parentheses, and we're going to add the x plus 7 that's still left. Now I have to multiply this polynomial times this binomial. So I'm going to go ahead and use the vertical method like I did before. So what I'm going to do is erase this and actually add it below. So x plus 7. All right. This is going to be fun. So 7 times 49. I'm going to actually need to look that up. That's pretty big. All right, so that's 343. Okay. 7 times 14x. So that gives me 98x. Okay. 7 times x squared. So that's a positive 7x squared. All right, move to the next term. Now I have an x. X times 49 is positive 49x. I'm going to put that under the 98x, so it's like terms. Then x times 14x. So x times x becomes x squared. The coefficient on x is 1, so 14 is still going to be our value, but it's going to give me x squared, so I'm going to put it under the 7x squared. And then I have one left. X times x squared gives me x to the third. So x to the third, making sure that I have my plus in between the 14x. All right, so we've gotten through all the multiplying, so now we add it all together for a final answer. 343 drops down. 98 plus 49, that's 147. X. Then 7 plus 14, so that's 21x squared. And the x third just drops. So x to the third plus 21x squared plus 147x plus 343. Just double check that because that's really big numbers. Well, it is correct. So we just ended up having a problem with that produced very large numbers. All right, so that does it for those type of problems. We're going to now move on to problem number 100. Okay. So 100, we have a more complex version of working with our rules that have to do with multiplying, dividing variables, raising it to a power, and we're also throwing in negative exponents. So what does it mean when you have a negative exponent? All right, so there's really two ways you can go about this. You can fix the negative exponent on the outside first, or you can switch the negative exponents in the inside, or you can also use the rule of a power raised to a power is to multiply it. Now, I do want to go ahead and review the strategy of how does a negative exponent work. So I'm actually going to kind of take the long way on this just because I want to make sure that you remember how negative exponents work. So what I'm going to actually do first is work the inside, okay? So I'm not going to do anything with that -3 just yet. So on the inside, anytime you have a negative exponent, what it means is you're taking its reciprocal. So all that means is if it's on the top, you move it to the bottom. If it's a negative exponent on the bottom, you move it to the top. And when you switch it to the top or bottom, you take away the negative sign. So I'm going to go ahead and draw another parenthesis set, another fraction sign, write it to the -3rd, and I'm going to go ahead and take care of my negatives here. So x to the -3, I'm going to move it to the bottom, so now it's x to the +3. X to the -2 now becomes on top x to the +2. Y to the -4th is going to go to the bottom as now x to the +4th. Y to the -5th on the bottom is now going to go to the top as y to the +5th. Okay, so now what I've noticed is I have x's on the top and the bottom, and y's on the top and the bottom. So that means I can use my division rule, which means I subtract the exponent in order to divide them. Now, what we have to pay attention here is the bigger number starting on the top, or is the bigger number starting on the bottom? And when I say number, I'm talking about the exponent. So let's start with our x's. Okay, so with the x, I have a 2 on the top and a 3 on the bottom. So I don't want to do 2 minus 3 because that's just going to give me a negative number again. I want to do 3 minus 2. So because I'm starting on the bottom with the bigger number, when I do 3 minus 2, that means, obviously 3 minus 2 equals 1. That means my answer, my x to the 1, is going to go on the bottom because the bigger number is on the bottom. So I'm just going to put x. I don't have to write to the 1 power. For my y, I have 5 on top, 4 on the bottom. This time, the bigger number is on top. So if I do 5 minus 4, I get the value of 1y, or y to the first power. So because I started with the bigger number on top, that means the y goes on top. Now, I still have this whole thing to the -3 power. So what I'm going to do now is I'm going to distribute this -3. So how do we do that? We just multiply the exponents. So both of these are an exponent of 1. So really, it's just going to end up being 1 times -3. So it's going to be -3. So if I distribute this, it becomes y to the -3rd, x to the -3rd. Oh, we have negative exponents again. How do you fix it? You switch it to the top or the bottom. So this y to the -3 is going to go to the bottom with a +3. This x to the -3 goes to the top with x to the +3, and that's your answer. All right, and that concludes us for page 365. So we're going to go ahead and move on to page 432. Okay, number 4. 6 and 8. Yeah, I might have to do these separately. Okay, so number 4. Remember, chapter 6 is focused on factoring, so it's the opposite of chapter 5. Chapter 5 is expanding or simplifying. Chapter 6 is working backwards. We are taking the simplified version and factoring it back into its parenthesis form. So how do we do that? We look for greatest common factors. So first look at your coefficients. In this, I'm looking for what do they both have in common. So I have a 6 and a 3. So that means the greatest common factor here is they both share a factor of 3. So I'm going to write 3. Then I look at my variables. Now variables have to be treated individually. So don't look at it as x, y. Look at it as x and then look at y. So x, we have x squared and just x. The rule of the variable is you have to go with the lowest exponent of any shared variable. So because there's both x's here, this is only to the first power, so I can only remove one x. The y's, they both have y's. This one has a 2, this one has a 3. I have to go with the lower one, so 2. Now, after you have your greatest common factor pulled out, then you write what's left behind. You do this by dividing. So 6 divided by 3 is 2. I had 2 x's, I removed 1, so now I have 1. Y squared, I had 2 of them, I took away 2 of them, so there's no more y's. The minus sign stays. 3 divided by 3 is 1, so I don't have to write coefficient 1. I just know there's no more numbers. I had an x, I removed the x, so no x's. Y to the third, I took away 2. I'm left with 1y, and that's my answer. All right, number 6. All right, so what makes this one different? We are able to factor here, but we don't have a common variable or a common coefficient that can be factored. In this case, we have a common polynomial, in this case, binomial. Notice in this term and this one, there is both an x plus 1. So this is factor by grouping. What we're going to do is remove the x plus 1 and then write in another binomial set what's left behind. So I start with my x plus 1. So if I remove the x plus 1's, what am I left with? I'm left with a 5x, a minus sign, and the coefficient here is an invisible 1. Okay, number 8. All right, so in this one, first scan and see, are there any like terms that all of them share? No, because although a lot of them have an A, this one doesn't. Although these two have a B, or these three have a B, this one doesn't. And even though all three of these share a factor of 3, this one doesn't. So when you notice none of them have anything in common, this is where it's basically your hint to say you got to do it by grouping. So when you do it by grouping, always start with the first 2 terms. So first 2, and then put a parenthesis set around the second 2. Now we're not saying that this is multiplying times this, we're just grouping it so we can factor out. So looking in the first group, what do they have in common? So starting with the coefficients, I have a 3 and a 9. They both share the common factor of 3. All right, moving to the next term. I have a squared and a. So they both have an a. Now I have to go with the lowest exponent. This has a 2, this has a 1. So I can only pull out that 1a. And then this one has a b, but because this doesn't have a b, I can't remove the b. So what's left behind? 3 divided by 3 is 1. A squared, so I had 2, I took away 1. I'm left with 1a. The plus sign is still there. 9 divided by 3 is 3. I had an A, I took it away. B is still there, it's left behind, and that's my first group. Now in the second group, you have to decide what sign is going to go here. How do you do that? Well, in this one, it's easy. They're both plus signs, so obviously it's going to be a plus, okay? So now I have to determine what factor I'm pulling out. So this one has a 3, this has a 1. I can't factor out a coefficient here. I have b squared, I have b. So they both have a b in common. This is a 2, this is a 1, I have to go with the 1. All right, now this a, because it doesn't have an a, I can't do anything there. So now what's left behind? In this first term, I have a 3, so that's still there. I had 2 b's, I removed 1, so that means 1b is still there. The plus sign is gonna stay. Then I have AB. So the A is still there. I had a B, I removed the B, so that means it's just going to be a single A. Now, reevaluate. What do you notice? So I have A plus 3B, and I have 3B plus A. They might be in reverse order, but they're being added. It doesn't matter that they're in a different order. It's the same term. So that means I can actually factor this out. So I'm going to factor out an A plus 3B. I'm going to go ahead and cross that off so I know it's gone. And then in another set, I'm going to write what's left behind. So when I remove this, I'm left with 3A, this plus sign, and B. Okay? All right, moving on to 12. All right, now we're moving into our trinomial problems where you have the formatting of x plus or minus a number times x plus or minus a number. So if you don't remember the rule, when this coefficient is 1, what you're looking for is factors of this number that add to this number. So I know I'm working with factors of 24. Before I start drawing all the factors of 24 though, I need to look at my signs. This tells me same signs or different signs. If it's a plus, that means same. So they're both going to be positive or they're both going to be negative, which means I need my factors of 24 to add to negative 11. So I'm looking for same sign factors to add to negative 11. So I'm going to start, I have negative 1, negative 24, negative 2, negative 12. So that's not right. Negative 3, negative 8. Okay, so that's our winner. Negative 3 times negative 8 gives me positive 24. Negative 3 plus negative 8 gives me negative 11. So once you have your answer, put in your sets, x and x, and then the sign from your factors. Minus 3, minus 8. Okay. 16. All right, so in this case, notice that we have an x squared and a y squared. So we're still solving it the same way because it's a coefficient of 1. But what's different is that instead of having it in my answer is x plus a number, or x plus or minus a number, or x plus or minus a number, we're still going to have x, but we're also going to have y. Okay, so anytime you have two variable sets of a squared and a squared, it just means that the left ones are going to be x and the right ones are going to be y. Well, really what I should say is the left set's going to be whatever this variable is, and the right ones are going to have the y's. Now, we still are going to have coefficients in these, so what we're going to do is now look at this number, 15. I need two factors of 15 to equal 8. Let's look at our signs. We have both positives. So that means I need two factors of 15 that add to positive 8. So I have 1 and 15. I have 3 and 5. 3 and 5, positive 3 and 5, both multiply to be 15 and add to be 8. So I'm going to put plus 3 plus 5. And you can check your work by using the FOIL method, and you should come out to this answer. All right, number 20. All right, anytime you do a problem that involves a polynomial, first thing is always look and see, is there anything I can factor out first? So what I'm noticing here is that 5, 50, and 120, they're all divisible by 5. So I need to factor out a 5, okay? So I'm gonna write 5. Now, I'm gonna look at my variables. I have a y to the third, a y to the second, and a y. They all have y, so I need to remove y. Which exponent am I using? 3, 2, 1, I have to go with the lowest one, which is 1. Okay, now write what's left behind. 5 divided by 5 is 1, so no more coefficient. Y to the third, I took away one of them, so that means I'm left with a y squared. 50 divided by 5, or I could say negative 50 divided by 5 is negative 10. I had 2 y's, I took away 1, so I'm left with 1 y. Plus, or sorry, not plus, but positive 120 divided by positive 5. That's going to be plus 25. No, it's not 25. 25 plus 4. So 29. No, that doesn't sound right. Hold on. I don't want to do this wrong. $24. Okay. All right, we had 1 y, we removed it, so there's no more y's. Okay, so now, because this factor is here, it has to stay with our problem the rest of the time. So I'm going to draw 5y, parenthesis, and then we're going to start breaking up our factors. Because notice we do have a trinomial in the form of squared y number. So what I need to do next is look at my signs. Positive 24 means that I have the same signs. What kind of signs? Negative. So I need to go through the factors of 24 that are going to add to be negative 10. So that gives me 1, 24, 2 and 12. Still none of those add right. 3 and 8, 4 and 6. There we go. So I have a positive 4 and a positive 6. So I'll have x plus 4, x minus, or sorry, x plus 6. And that's your final answer. All right, 24. All right, so on this one, we have a coefficient larger than 1 in front of the x squared. So what that means is that we have to use a different rule. Anytime this is larger than 1, what you need to do is find factors of a times b that equal the middle number. So I'm not just looking for factors of 3, I'm looking for factors of 4 times 3. So 4 times 3 is 12. So we still want to look at our signs though. This is negative. So I'm going to be looking for different signs. One of these numbers, one of these factors of 12 is going to be positive, one is going to be negative, and because one's positive and negative, that means that they're going to be subtracting rather than adding. So I need 2 factors of 12 that subtract to equal 4. So we have 1 and 12. We have 2 and 6. Oh, that's it. 2 and 6. So if I subtract 2 and 6, it will give me 4. Now, here's what I have to do before I put my answer in. I need to determine what the sign is going to be. So what I need to look at is this middle number. I need them to subtract so that they equal positive 4. So is it 2 minus 6 or 6 minus 2 that gives me positive 4? In this case, 6 minus 2 is positive 4. So now here's where it's different from our last method. Instead of putting this all in parentheses, what we're going to do is 4x squared. We're going to rewrite substituting these numbers in for 4x. Minus 2x plus 6x minus 3. The next step is to factor by grouping. So the first 2 and the last 2. In the first 2, I have a 4 and a 2, so that means I can pull out a 2. I have an x squared and an x, which means I can pull out an x. What's left behind? 4 divided by 2 is 2. I had 2 x's, I removed 1, so I still have an x. minus, I had minus 2x and I removed 2x. What's the rule when you remove the entire same factor? You're left behind with a 1. Okay, moving on. Because this is plus 6x, that means I'm going to go ahead and factor out a positive number. Now, looking between these two, 6 and 3, they both have the factor of 3, and that's the only same factor that they share. So what's left behind? 6 divided by 3 is 2, the x remains. The minus sign stays, and 3 divided by 3 is 1. Now what do you notice? Same group. So we're going to factor out a 2x minus 1. Cross that out. What's left behind? 2x plus 3. And that's my answer. Okay. Almost there. 4 more problems. Okay, 28. All right, look at my problem. Is there anything I can factor out ahead of time? Always ask that first. So in this case, I'm noticing they do all have a y. 39. Yes, so with 39, 60, and 6, we can factor out a 3 as well, okay? So let's go ahead and pull out a 3 and a y and write what's left behind. 60 divided by 3 is 20. Y to the third, I remove one of them, so I'm left with y squared. 39 divided by 3 is 13. So minus 13. We have y squared, we removed 1, so we're left with y. Plus 6 divided by 3 is 2. Y, we removed it. So now I'm left with a trinomial in the form of squared, one variable, and a number. So that means I can go ahead and move forward with factoring further. Now, in this case, this coefficient is larger than 1. So we do have to continue using the method of this number times this number. So 20 times 2 is 40. I need factors of 40 in this problem. So what are we doing with factors of 40? This number is positive. So that means I need two numbers of the same sign that add to negative 13. So because this is positive, that means I'm going to do all my factors negative. We're adding them together to equal negative 13. So because this is a smaller number, I don't want to go through my huge factors of 40 like say 1 and 40. So I'm going to start with 4 and 10. Okay, that's not going to work. 5 and 8. And that looks like our winner. Oh, sorry, I should be doing these negative. So we have negative 5 and negative 8. So now, because this is a larger coefficient than 1, we are using the grouping method. So this 3y being factored out in the beginning does mean we have to keep it. So I'm going to write 3y, and I'm going to rewrite my problem with my new factors. 20y squared minus 5y minus 8y plus 2. All right, so now I move into my grouping method. So in this case, the first two going to get grouped, and the last two are going to get grouped. Okay, so I'm going to rewrite. Once again, 3y. But this time I'm going to put it in brackets so I don't get it confused with my parentheses. So in the first grouping, 20 and 5, I can factor out a 5 because they both have the factor 5 in common. Of the y's, I have a y squared and a y, so I can only remove one y. What's left behind? 20 divided by 5 is 4. Y squared, I remove 1, so I have a y minus 5 and y, same exact term. So what happens is it's 1. Okay, now on this one, this is a minus sign. So what that means is I'm going to factor out a negative. So by putting this negative here, that means everything in this parenthesis group is changing signs. Okay, so I have minus, and now I'm going to look at my factors, and then we'll look at how the signs are affected. So 8 and 2. I can factor out a 2 between those. This is a y, this doesn't have a y, so that's all I can factor out. So what I'm going to do is negative 8 divided by negative 2. That gives me positive 4. Y is still there. Positive 2 divided by negative 2 is negative 1. Now look what happened. We have the same term in both of these. So I'm going to factor out a 4y minus 1. Now because this 3y is here, once again, it does need to remain. So because I am, oh sorry, I guess I should have had another bracket there. Because I now have my parentheses kind of situated, I don't necessarily need the bracket anymore. So I'm just going to write 3y parenthesis 4y minus 1, and then what's left behind when I take away the 4y's minus 1? 5y minus 2. That's it. Okay. All right. So notice this is a binomial. We're not using our trinomial rules anymore. But something I also want to point out, this is a minus sign. Anytime you see a binomial with a minus sign, that should ring a bell that, oh, I should probably check and see if it's a perfect square minus a perfect square, because there's a rule that goes with perfect square minus perfect square. So in my coefficients, both of them have to be perfect squares. So 9, is that a perfect square? The answer is yes. 25, is that a perfect square? Yes. So just a reminder, perfect square means the same number times the same number equals that number. Now looking at my variables. For variables, they don't have to be the same ones. They can be different ones. But the thing you're looking for is it an even number? As long as it's an even number, it's a perfect square. So I see a 2 and a 2. Those are both squares. So in this, the rule is take the square root of the first term. So the square root of 9 is 3. To do it for the variable, you divide it by 2. So 2 divided by 2 is 1, so 1t. And you write that twice. Then take the second term. The square root of 25 is 5. 5 times 5 is 25. Then s squared, 2 divided by 2 is 1, so 1s. Then to finish it off, 1 gets a plus, 1 gets a minus. All right, 34. Actually, I think I'm going to erase this and do it higher up because I need a little bit more. I just want to have more space. Okay. Okay, so on this one, notice we have a third and a third. Obviously not a perfect square minus perfect square. But something I want to point out too is that there is a rule for a perfect cube minus a perfect cube. And there's also a rule for a perfect cube plus a perfect cube. So cubes also have their rules. This is the one where you end up putting it into the formatting of a binomial times a trinomial. So we're gonna work through that process. You always start with the binomial. So in the binomial, if you notice, oh, it's a cube root minus a cube root, then we're gonna do this process. So the cube root of x, so what times what times what equals x to the third? You do that by dividing the exponents of a variable by 3. 3 divided by 3 is x. Whatever this sign is the same sign in the first binomial. 8, what's the cubic root of 8? What times what equals 8? 2. Y to the third, so 3 divided by 3 is 1, so I'll have 1y. Now, the next one is going to be a trinomial. And if you don't remember this formatting, it is back in chapter 6. I think it was section 6.5 that you'll need to reference back to. Okay, so going through the trinomial, it's the squared version of this term. So if I take the square version of x, then it becomes x squared. Now the sign in the trinomial, the first sign is always the opposite of what's in the binomial. So if this is negative, this is positive. All right, then our middle term of the trinomial is this times this. So x times 2y. Always put the coefficient first, then go in alphabetical order. So it'd be x and y. The last sign, always positive. And then the final term is this is the second one in your binomial squared. So 2 squared is 4 and y squared. And that's it. All right, we got one more problem. Let's see, I think I am gonna erase this. Okay, 39. All right, so what do you notice about this one? Obviously, it's not a cube like we just had, but it is a perfect square minus a perfect square. 16 is a perfect square. X to the fourth. Remember I said all it has to be on the variable is even. It can be any number. It can be a large number. It just has to be even. And 1. 1 times 1 is 1, so that's a perfect square. So I'm going to go ahead and break this up into my binomial times binomial. So 16, square root of that is 4. Write that twice. The way you square the exponent is by dividing it by 2. So 4 divided by 2 is x squared. Write that twice. Spread this out a little. And then square root of 1. So obviously 1. 1 times 1 is 1. And for the signs, 1 is positive, 1 is negative. Now you would think, okay, I'm done. I finished my problem. But don't just assume that you're done. Always evaluate your binomials, because what you may not have caught is the fact that we still have a perfect square minus a perfect square, which means we can continue factoring. In this one, 4, you can take the square root of it. X squared, you can take the square root of it. 1, you can take the square root. So what I'm going to do is go ahead and rewrite this one. If it's a plus sign, you can't factor that any further, but if, with a minus, you can. So I'm going to draw another set of binomials, and I'm going to factor my perfect square minus perfect square. So with 4, if I take the square root of that, 2 times 2 equals 4. So I write 2 twice. X squared, 2 divided by 2 is 1. So I have an x and an x. The square root of 1, 1 times 1 is 1. So 1 and 1 plus minus, and that's your final answer. All right. So that concludes the problems you were supposed to do. It did occur to me when I finished chapter 5, though, that it did not have any review problems on scientific notation. So I'm just going to make up 2 random scientific notation problems because it is on the test, just to help you remember and review. So I want to say what's on the test is you taking it from scientific notation form and putting it into standard form. So that's how I'm going to show you. So let's say we have 400. Oh, actually, I'm doing it backwards. I want you to take scientific notation and put it in standard. So let's say we have 4.2 times 10 to the 5th. And we have, not 4. Say we have 9.01 times 10 to the negative 4th. All right, so with these, if I take it into scientific notation, if it's a positive exponent, that means I'm making it bigger. So that means I'm moving the decimal to the right 5 places. So let's do that. 1, 2, actually I'm going to rewrite it so I have space. So 4.2, I move it 1, 2, 3, 4, 5. What do you do to these empty holes? Well, you fill it in. So that means my final answer would be 4, 2, 0, 0, 0, 0. Okay, you don't have to worry about putting a comma in. All right, when it's negative, that means I'm making the number smaller. So I'm moving the decimal to the left. So I have 9.01 and I'm moving it 4 places left. So now my decimal is here. What do I do to the empty spaces? I fill it with a 0. So my final answer would be 0.000901. Okay? All right, and I can't remember if I put on the test a question. Actually, just let me look it up really quick. Okay, I do have both types, so I'm going to show you as well. If I give you a number, how to put it in scientific notation. So we have 8, 1, 0, 0, 0, 0, 0. And we'll do 0.0000345. All right, how do I take this and put it in scientific notation? So you always want to find the decimal. Think of it as money. If I have this much money, where is the decimal? Where do I start my cents? At the end. So here's my decimal. The first step is to move your decimal to another spot to make the value between 1 and 10. So 1, 2, 3, 4, 5, and I want to end it between the 8 and 1 because 8.1 is a value between 1 and 10. How many places did I move it? So count how many dips you have. 1, 2, 3, 4, 5, 6. So I'll take my number now, 8.1. And the way you know how far to go out is once you get to the first non-zero, you're done. So once I get to 8.1, I don't have to write these other zeros. Times 10. How many places did I move it? 6. So how do I know if this is positive or negative? If it's a number larger than one, if it's a number larger than 1, yeah, because this is less than 1. So if it, basically just think of it this way. If it's a big number, it's a positive exponent. This is a very small number. We would not want this much money in our bank account. So in this case, we're going to end up having a negative exponent, but we still need to start with the move the decimal rule. So 1, 2, 3, I'm going to move it in between the 3 and the 4 because that gives me a value between 1 and 10. Now on this, notice that I have 3.4. Don't leave out the 5. Remember, you write the entire number of the decimal till you have a non-zero. 5 isn't a 0, so that is included. So 3.45 times 10. How many places did we move it? 1, 2, 3, 4. And that is negative because this number was less than 1 to begin with. It was a small number. All right, so I think I've covered on everything. Feel free to go back and watch anything else that you needed to. Even though this is the review, the nice thing about how this learning process is going, even though it's not an ideal situation because we usually meet in class, you can always go back to the chapter section videos and rewatch anything that you need help on. Anything that's on the test, I have covered at some point. So there is me doing an example. So it's something you can go back and rewatch. The homework assignment for chapters 5 and chapter 6, those are due on Friday. This review is not a homework assignment. This is something that I was hoping you would do to reinforce your learning and feel prepared for the test. You can start the test anytime, but the last date that you can take it is the 27th. So make sure you don't start it on the 27th because you get 3 attempts. And if you start it on the 27th, that means you have to do all 3 attempts on the same day. So, I mean, if that's what it comes to and that's what you end up doing, then that's your choice. I want you to take it when you're ready. But I'm not extending the test date after the 27th because chapter 8 needs to be finished by May 5th. Okay, so just make sure that you're aware of that. And if you have any questions, please feel free to send me a message on Remind or an email. All right, thanks. Bye.